Good day, students. So this is your Mathematics 9 subject. So going to have your Quarter 1, Module 3, entitled Equations Transformable into Quadratic Equation. What you need to know in this lesson, so at the end of this lesson, you are expected to solve equations transformable into quadratic equations, so including rational algebraic equations. So before we proceed with the discussion, let us first have your review. For the first part of our review, we have solve for the roots of the quadratic equations. The first given is x squared plus 7x plus 12 equals 0. In this equation, we will use the factoring method. The first step is determine the factors of the first term. The factors of x squared are x and x. Next, determine the factors of the last term. The factors of 12 that will give us the sum of 7 are positive 3 and positive 4, since 3 plus 4 is 7. And this is now our factors. After that, equate each factors to 0 and solve for the values of the variable. For x plus 3 equals 0, transpose positive 3 to the right side. Remember to change the sign as you transpose the term. We have now x equals negative 3. Next, for x plus 4 equals 0, transpose positive 4 to the right side. And it will become x equals negative 4. And these are the values of the variable, negative 3 and negative 4. For the next given, we have 2x squared minus 7x plus 3 equals 0. Again, we will use the factoring method to solve this equation. Same steps. First, the factors of the first term. The factors of 2x squared are 2x and x. Next, the factors of the last term. The factors of 3 are negative 1 and negative 3. Now, let's check if the obtained factors are correct. Multiply the inner terms. Negative 1 times x is negative x. Next, the outer terms. 2x times negative 3 is negative 6x. Then add these two products. Negative x plus negative 6x is negative 7x. The answer must be similar to the middle term of the given. Since they are similar, these are the correct factors. Next, equate each factors to 0. And then solve for the values of x. For 2x minus 1 equals 0, transpose negative 1. And this is now 2x equals 1. Then divide both sides by 2. For the left side, cancel 2 on the numerator and denominator. The answer now is x equals 1/2. And for x minus 3 equals 0, transpose negative 3. And the value now is x equals positive 3. And these are the values of x. I hope you already recall how to solve quadratic equations by factoring. Let us now proceed with the second part of the review. Determine the least common denominator or LCD of the following. Number 1, 1 over 3 minus 2x over 9. What is the LCD between 3 and 9? Okay, so the LCD is 9. For number 2, x over 7 plus 5 over x. What is the LCD between 7 and x? Very good. The LCD is 7x. Number 3, 11 over 4x plus x over 12. So the LCD of 4x and 12 is? That is correct. The LCD is 12x. For number 4, 3 over 5 minus x over x plus 5. So the LCD of 5 and x plus 5 is? So that is correct. The LCD is 5 times quantity x plus 5. Number 5, x over x minus 2 plus 7 over x plus 4. So what is the LCD between x minus 2 and x plus 4? Correct. The LCD is quantity x minus 2 times quantity x plus 4. Now, let's proceed with the last part of our review. Perform the indicated operation in each number. Number 1, 3 over x minus 5x over 6. First step, determine the LCD of x and 6. The LCD is 6x. Then, 6x divided by x, we have 6 times 3, 18. Next, 6x divided by 6 is x, times negative 5x is negative 5x squared. And this is the answer for number 1. Next, for number 2, 2 over 3x plus x over 15. Same step, determine first the LCD of 3x and 15. The LCD is 15x. 15x divided by 3x is 5, times 2 is 10. Next, 15x divided by 15 is x, times x is x squared. And this is now the answer for number 2, 10 plus x squared over 15x. For number 3, the given is 3x over 4 plus 1 over x plus 3. So what is the LCD of 4 and x plus 3? Okay, so the LCD is 4 times quantity x plus 3. So now, LCD divided by 4 is x plus 3 times 3x is x plus 3 times 3x. Next, LCD divided by x plus 3 is 4 times 1 is 4. Now, let's simplify the numerator. 3x times x is 3x squared. 3x times 3 is positive 9x, and then copy positive 4. And this is now the answer for number 3. 3x squared plus 9x plus 4 over 4 times quantity x plus 3. For number 4, we have x over x plus 1 plus 2 over x minus 2. So the LCD of x plus 1 and x minus 2 is quantity x plus 1 times quantity x minus 2. So LCD divided by x plus 1 is x minus 2 times x is quantity x minus 2 times x. Next, LCD divided by x minus 2 is x plus 1 times 2 is 2 times x plus 1. So simplify the numerator. We're going to distribute x to the quantity x minus 2. X times x is x squared. X times negative 2 is negative 2x. So same with 2 times quantity x plus 1. 2 times x is positive 2x. 2 times 1 is positive 2. And then simplify the numerator. So copy x squared. Then cancel negative 2x plus 2x. Then copy positive 2. And the answer now is x squared plus 2 over quantity x plus 1 times quantity x minus 2. And that is the last part of our review. Now, we will proceed with our topic. So our topic is divided into 2 lessons. The first lesson is solving quadratic equations that are not written in standard form. And in order to understand this lesson, let's have the different examples. Example number 1 is solve x times quantity x plus 5 minus 14 equals to 0. So example number 1 is not yet written in standard form. So meaning, the first step is to write the quadratic equation in standard form. So we have the equation. The first step is to distribute variable x to the quantity x plus 5. So x times x is x squared. X times 5 is positive 5x. Then bring down negative 14 equals 0. And it is now written in standard form. Step number 2, solve for the roots using any method. So we will try to use the factoring method. So use the standard form of the equation. So first step, determine the factors of the first term. So the factors of x squared are x and x. And the factors of the last term, which is negative 14, that will give us the sum of positive 5 are 7 and negative 2. Because 7 minus 2 is 5. and then equate each factors to 0. So for x plus 7 equals 0, transpose positive 7 to the right side, and this is now x equals negative 7. Then for x minus 2 equals 0, transpose negative 2 to the right side, and this will give us x equals positive 2. And the values now of the variable x are negative 7 and positive 2. So for step number 3, check whether the obtained values of x make the original equation true. So for the first obtained value, we have negative 7. So from the original equation, substitute negative 7 to the variable x. So we have negative 7 times quantity negative 7 plus 5 minus 14 equals 0. So we have negative 7. Then negative 7 plus 5 is negative 2. Then bring down negative 14 equals 0. Next, negative 7 times negative 2 is positive 14. Again, bring down negative 14 equals 0. Then 14 minus 14 is 0. So 0 equals 0. And this is true. For the second obtained value, we have 2. Again, from the original equation, substitute 2 to the variable x. So we have 2 times quantity 2 plus 5 minus 14 equals 0. So we have 2. 2 plus 5 is 7. Then bring down negative 14 equals 0. 2 times 7 is positive 14. Again, bring down negative 14 equals 0. And 14 minus 14 is 0. So 0 equals 0. Again, this is true. Since both values of x makes the equation true, then the roots are negative 7 and positive 2. And that is example number 1. Now let's proceed with example number 2. What are the roots of the equation quantity x plus 3 square equals x times quantity 2x plus 6? First step, write the quadratic equation in standard form. So we have the given. So for the left side, this is called square of binomial. So there are 3 steps to simplify the square of binomial. First step, square the first term. So square of x. Step number 2, twice the product of the first and last term. So twice the product of the first term, which is x, and the last term, which is 3. Third step, square the last term. So square of 3. And for the right side, we will distribute x to the quantity 2x plus 6. So x times 2x is 2x squared. Then x times 6 is positive 6x. And then let's simplify. X squared is x squared. 2 times x times 3 is positive 6x. Then 3 squared is positive 9. Then we will copy positive 2x squared plus 6x. Next step, transpose x squared plus 6x plus 9 to the right side. We have now 0 equals 2x squared plus 6x minus x squared minus 6x and minus 9. And then let's simplify the given equation. So for 2x squared and negative x squared, so we have x squared. For 6x and negative 6x, so cancel. Then copy negative 9. Then simplify. We have now x squared minus 9 equals 0. And this is the standard form of the given equation. Step number 2. Solve for the roots using any method. Try extracting the roots since the linear term is 0. So we have the standard form of the equation. First step, transpose negative 9 to the right side. So negative will become positive. So x squared equals 9. And then take the square root of both sides. So for square root of x squared, the answer is x. The square root of 9 are positive and negative 3. So the answer now are x equals negative 3 and x equals positive 3. For step number 3, check whether the obtained values of x make the original equation true. So for the first obtained value, we have negative 3. So from the original equation, substitute negative 3 to the variable x. So we have Negative 3 plus 3 square equals negative 3 times quantity 2 times negative 3 plus 6. Negative 3 plus 3 is 0, then square. Bring down negative 3. So 2 times negative 3 is negative 6, then copy positive 6. 0 square is 0. Again, bring down negative 3. Negative 6 plus 6 is 0. And negative 3 times 0 is 0. And this is true. For the second obtained value, which is 3, again, from the original equation, substitute 3 to the variable x. So 3 plus 3 square equals 3 times quantity 2 times 3 plus 6. So 3 plus 3 is 6 and then square. Bring down 3. 2 times 3 is 6, then copy positive 6. 6 square is 36. Again, bring down 3. 6 plus 6 is 12. And 3 times 12 is 36. And this is true. Since both values of x makes the equation true, then the roots are negative 3 and positive 3. And those are the examples of lesson number 1. So I hope you understand how to solve quadratic equations that are not written in standard form. So again, the 3 steps are: first, write the quadratic equation into standard form. Step number 2, solve for the roots of the quadratic equation using any method. Step number 3, check whether the obtained values of x make the original equation true. Let us now have the second part of the lesson. Lesson number 2. Solving rational algebraic equations transformable into quadratic equations. So before we proceed with the different examples, let us first define what do we mean by rational equations. Rational equations are equations in fractional form with some variables in the denominator. It is sometimes known as fractional equation. Let us now have the different examples. The first example under lesson number 2 is solve rational algebraic equation 8 over x plus x over 2 equals 5. First step, determine the least common denominator or LCD of the given equation. The LCD of x and 2 is 2x. Next step, multiply the whole equation by the LCD. So 2x times 8 over x plus x over 2 equals 5. So in order to multiply these two, we will distribute 2x to the given equation. So 2x times 8 over x is 16x over x. Next, 2x times x over 2 is 2x squared over 2. And then last, 2x times 5 is 10x. So for 16x over x, so cancel x in the numerator and denominator. So we have now 16. So for 2x squared over 2, cancel 2 in the numerator and denominator. So we have x squared. Then bring down 10x. Next step, transpose 10x to the left side and then simplify. The equation now is x squared minus 10x plus 16 equals 0. And this is now the standard form. Step number 3, solve for the roots using any method. So use the standard form of the given equation. So since the standard form is factorable, we will use the factoring method. So the factors of x squared are x and x. The factors of 16 that will give us negative 10 are negative 2 and negative 8, because negative 2 plus negative 8 is negative 10. Next, equate each factors to 0. For x minus 2 equals 0, transpose negative 2 to the right side. This will become x equals positive 2. For x minus 8 equals 0, transpose negative 8 to the right side, and this will be x equals 8. And these are the values of the variable x equals 2 and x equals 8. Step number 4, check whether the obtained values of x make the original equation true. The first obtained value is positive 2. So from the original equation, substitute 2 to the variable x. So we have 8 over 2 plus 2 over 2 equals 5. 8 divided by 2 is 4. 2 divided by 2 is positive 1. Then bring down 5. 4 plus 1 is 5. And 5 is equal to 5. And the equation is true. For the second obtained value, which is 8, again, from the original equation, substitute 8 to the variable x. So 8 over 8 plus 8 over 2 equals 5. 8 divided by 8 is 1. 8 divided by 2 is positive 4. Then bring down 5. 1 plus 4 is 5. And 5 is equal to 5. So true. Since both values of x makes the equation true, then the roots are 2 and 8. Let us now have the next example. Solve the rational algebraic equation 5 plus x over x plus 6 over x squared equals 0. First step, determine the least common denominator or LCD of the given equation. The LCD between x and x squared is x squared. Step number 2, multiply the whole equation by the LCD. So x squared times 5 plus x over x plus 6 over x squared equals 0. So distribute x squared to the given equation. X squared times 5 plus x over x is x squared times quantity 5 plus x over x. Next, x squared times 6 over x squared is 6x squared over x squared. Then last, x squared times 0 is 0. So for the first term, we will divide x squared and x. So x squared divided by x is x. Then copy 5 plus x. So for 6x squared over x squared, cancel x squared. So we have now positive 6. Then bring down equals to 0. Next step, we will distribute x to the quantity 5 plus x. So x times 5 is 5x. X times x is positive x squared. Then copy plus 6 equals 0. Then simplify the equation. So we have now x squared plus 5x plus 6 equals 0. And this is the standard form of the equation. For step number 3, solve the roots using any method. So use the standard form of the given equation. And since the standard form of the equation is factorable, we will use the factoring method. So first, factors of the first term. So the factors of x squared are x and x. Then, the factors of the last term, which is 6. So the factors of 6 that will give us a positive 5 are positive 2 and positive 3. Next, equate each factors to 0. So for x plus 2 equals 0, transpose positive 2 to the right side. And this will become x equals negative 2. Next, x plus 3 equals 0. Transpose positive 3 to the right side. And this will be x equals negative 3. And these are the values of the variable. X equals negative 2 and x equals negative 3. Step number 4. Check whether the obtained values of x make the original equation true. So the first obtained value is negative 2. So substitute negative 2 in the original equation. So 5 plus negative 2 over negative 2 plus 6 over negative 2 squared equals 0. So 5 plus negative 2 is 3, then over negative 2. Negative 2 squared is 4. Then we have now plus 6 over 4, then equals 0. So use the least common denominator to simplify the given fraction. Then we have now negative 6 plus 6 over 4 equals 0. Negative 6 plus 6 is 0. So over 4 equals 0. 0 over 4 is 0. And 0 is equal to 0. So this is true. For the second obtained value, which is negative 3, so substitute negative 3 on the original equation. So we have 5 plus negative 3 over negative 3 plus 6 over negative 3 squared equals 0. So 5 plus negative 3 is 2 over negative 3. And negative 3 squared is 9. So we have 6 over 9 equals 0. So using the LCD of the given fractions, so we have now negative 6 plus 6 over 9 equals 0. So negative 6 plus 6 is 0, then over 9 equals 0. So 0 over 9 is 0, and 0 is equal to 0. So true. So since both values of x makes the equation true, then the roots are negative 2 and negative 3. Let us now have the last example. Solve the rational algebraic equation 2 over x minus 1 plus 3 over x equals 0. First step, determine the LCD of the equation. So the LCD is x times quantity x minus 1. Step number 2, multiply the whole equation by the LCD. So LCD times the given equation. So LCD times 2 over x minus 1 is 2 times x times quantity x minus 1 over x minus 1. Next, LCD times 3 over x is 3 times x times quantity x minus 1 over x. Then last, LCD times 2 is 2 times x minus 1. Let's now simplify each term. So for 2 times x times quantity x minus 1 over x minus 1, so cancel x minus 1. So we have now 2 times x. So for the term 3 times x times quantity x minus 1 over x, so we will cancel x. Then we have 3 times quantity x minus 1. Then we have 2. Then we will distribute x to the quantity x minus 1. X times x is x squared. X times negative 1 is negative x. And then simplify each term. 2 times x is 2x. Then distribute 3 to the quantity x minus 1. 3 times x is 3x. 3 times negative 1 is negative 3. Then distribute 2 to the quantity x squared minus x. 2 times x squared is 2x squared. 2 times negative x is negative 2x. Next step, we will transpose 2x plus 3x minus x to the right side. So we have now 2x squared minus 2x minus 2x minus 3x plus 3. So bring down first, 0 equals 2x squared. Then combine negative 2x minus 2x minus 3x. And the answer is negative 7x. Then copy plus 3. Then we have now the equation 2x squared minus 7x plus 3 equals 0, which is our standard form. For step number 3, solve for the roots using any method. So use the standard form of the given equation. So since the standard form is factorable, we will use the factoring method. So the factors of 2x squared are 2x and x. Then the factors of positive 3 that would lead us to negative 7x are negative 1 and negative 3. Next, equate each factors to 0. So for 2x minus 1 equals 0, so transpose negative 1 to the right side, and this will be now 2x equals 1. Then divide both sides by 2. So cancel 2 in the numerator and denominator. And the first value now of x is 1/2. For x minus 3 equals 0, transpose negative 3. And this will be x equals 3. And the values now of x are 1/2 and 3. Step number 4. Check whether the obtained values of x make the original equation true. So the first obtained value is 1/2. So substitute 1/2 to the variable x in the original equation. So we have 2 over 1/2 minus 1 plus 3 over 1/2 equals 2. So for 1/2 minus 1, the answer is negative 1/2. So we have 2 over negative 1/2. And then for 3 over 1/2, the answer is positive 6. Then equals 0. So for 2 over negative 1/2, we have negative 4. Then bring down plus 6 equals 2. So negative 4 plus 6 is 2. And 2 is equal to 2. So this is true. For the next obtained value, which is positive 3, again, substitute 3 to the variable x in the original equation. So we have 2 over 3 minus 1 plus 3 over 3 equals 2. 3 minus 1 is 2. So we have 2 over 2. Then 3 divided by 3 is 1. Then copy equals 2. So 2 divided by 2 is 1. Then bring down plus 1 equals 2. So 1 plus 1 is 2. And 2 is equal to 2. So since both values of x makes the equation true, then the roots are 1/2 and 3. And that is the last example for lesson number 2. So I hope you understand all of the given examples for the 2 lessons. So with that, congratulations! So reminders, now that you finished this video lesson, you may now answer the what's more part of your module. So on pages 13 to 19. So thank you and good luck!